In this session, we're going to look at unions. So unions are the last of our aggregate data types. So we've talked about arrays, strings, structures, and now unions. Now we don't use unions a whole lot, but occasionally you'll find applications for them in embedded systems where we're talking about registers that share physical space. Well, that's what a union is and can do for us in C, is to actually physically share the same space between different variables at different times. So let's take a look at how we can do that. So as I've said, a union is an aggregate data type, which means it's a collection. The different thing about it is that even though we have a collection of variable names, we only have one value. And that value sits in that shared space. So if I have three fields defined in my union, for example, A, B, and C, I can access A, I can access B, or I can access C. How much space does it reserve? Enough for the largest of that A, B, and C elements. So let's take a look at how we define unions. Just like structures, we need to define a union before we can reserve memory for it. So we're going to start with the keyword union. Then we're going to give it a name, so I'm going to call it shared, just so we remember that it's shared space. And then I'm going to define all the fields that I want to share that space. So it looks very much like a structure. The only difference is now we're going to use the keyword union instead of shared. And in this case, because we have an integer, which takes 2 or 4 bytes, depending on the platform, we have a character, which always takes 1 byte, and then we have a float, which takes 8 or 4 bytes, depending on the platform, we're going to reserve enough memory to hold a floating point number. So we're going to return this space. So let's say it takes 4 bytes for our floating point number. If we use an integer, it's going to use half. If we use a character, it's going to use a quarter. And if we use a float, it's going to use the whole amount of space. Once we've defined our union, we declare it, again, just like structures. We're going to use the keyword union followed by the name we gave our structure, so that's our data type, and then we give it a variable name. So when we use it to access, we're going to use info. This part is our data type. Once we've declared space for our union, we can now start accessing the fields. So I had declared an integer field in there, which I called iValue. So again, we're just like a structure, we're going to use the dot operator. So the name of my field, the dot operator, and then the field name. And it was an integer, so we can assign something like 22 or 147. Any value that we'd assign to an integer variable, we can assign to that space inside our union. Now, if I wanted to use the character that I had inside, I could prompt the user and I could read in a character and assign it to the address of the character field inside that union. Now, remember, we're talking all the same space. So when I assigned the integer, it would have gone into half of the space. Now that I'm working with a character, it's going to go in a quarter of that space. Finally, if I want to print out the floating point number from there, here's my union, my dot operator, and the field name. Because it's a floating point, it's going to take the information from all of the space and print that out as a floating point number. So as you can imagine, if you're mixing and matching your use of the fields inside that union, you might get some pretty strange results if you try to print the biggest value. So what normally happens is you would define a union to declare information that logically shares the same space. Just as we wanted to with structures, there are many times that we want to pass a union into a function in order to use the information that's already there. So if we take a look, here's a function that's going to print values, and it's going to print information from our union that's called info. The function itself has to be set up to expect a union to be passed in. So we're going to pass in data, and then we're going to print, in this case, the integer value from that. So I have my union name, my dot operator, and the field name. If, on the other hand, we want to pass that union in order to be able to change the fields, we're going to pass in the address of the union. So remember that address operator that we've been using with scanf? Well, we're going to use that here. And here, this one is called a dereferencing operator, and we're going to talk more about this in Unit 7 when we talk about pointers. So a dereference operator, and that says that we have that space that was reserved for our union, and what we're passing in is where that space is. So kind of like what we've done with arrays. So here, there's the pointer that I have that accesses the space. This one is pointer notation. And so it is a minus sign followed by a greater than symbol. And what's going to happen here is I'm going to assign the character D to the character field inside here. So this is just a way of pointing to some space and being able to store a value in that space.